The rule for differentiation is if you have y equals x to the power of n, then dy by dx is equal to n x to the n minus 1. You bring the power down and you subtract 1 from the power, and that can be proven using algebra. So basically, in this question, we need to try to get each of these y equals into this form, x to the n. That's the end goal. So for the first one, well, I'm going to square, it's 3x all squared, so I've got to remember to square the 3 and square the x. It's going to be 9x squared times x to the 4 over x. Now I can add the powers here, so it's going to be x to the 6, and then divide by x, minusing 1 from it. I'm going to get 9x to the 5. And there's one thing I didn't actually say that I should have done, and that is actually we can go beyond just having y equals x to the n. If I have y equals k x to the n, then the constant just kind of, just passes through and we just have to times by that as well at the end. So here, dy by dx will equal 9 times 5x to the 4. I brought the 5 down, I've reduced it by 1, just like I'm doing here. So I'm going to get 45x to the 4. You do need to combine those two. Okay, part 2, we've got that y is the cube root of x. And that means it's equal to x to the third. And therefore, dy by dx is going to equal a third, x to the minus 2/3. When I do a third minus 1, it's actually the same as a third minus 3 over 3, which is minus 2/3. You might know to go straight to it, but that's the reason why. You could write that in back in fractional notation form. I think I would personally just leave it like this. It doesn't say we have to leave our answer in a particular way, but just for fun, well, it would be 1 over 3 x to the 2/3, because I'm basically I can bring it together. I can write this as 1 over x to the 2/3, but then I can multiply two fractions to bring it like this, and then it could be 1 over 3 cube root of x squared. But I personally think that looks better anyway. Okay, the last one is y equals 1 over 2x cubed. Now, a mistake sometimes made here is to try and differentiate the top and differentiate the bottom or something like that. No, we've got this one rule that we can use. It has to be written in the form a constant times x to the n. So I'm going to separate it into a half times 1 over x to the 3. A bit like I sort of undid it here, but and put it back in. It's actually a half. You need that there. And that's going to give me a half x to the minus 3. It might be tempting to write 2x to the minus 3, but that's not correct. It is a half x to the minus 3. Then it's in the right form. dy by dx is a half times minus 3x to the minus 4. I'm minusing 1 from minus 3. And that'll give me minus 3 over 2. I would just bring that together to a single fraction, x to the minus 4. Personally, I think, again, that is absolutely fine. You could instead write it as minus 3 over 2x to the 4, which looks pretty neat. Both are okay.